Good morning. I'm going to start by going over the homework that you had for last night. So I had asked you to do page 8 and page 9, numbers 1 and number 3 on both pages. So we'll start with going over that. You had to give the name, formula, and the electron dot for each ionic compound. So in this case, you're given the name, so you're going to be finding the formula and the electron dot. And then number 3, you were given the formula, so you'll be naming it and doing the electron dot. All right, so lithium. So if we look up, lithium has 1 valence electron, and sulfide or sulfur has 6 valence electrons. So we're going to put our 6 valence electrons. So lithium is going to give 1 electron to the sulfur, and you want to make sure that you use an arrow. So now lithium has lost its 1 electron. It's very happy. Sulfur has only gained 1 though. It needs another one. So another lithium comes along and is going to donate or transfer an electron to the sulfur. So we end up with lithium. The lithium gave 1 electron, so it has a +1 charge. But there are 2 of them. And then our sulfur has 1, 2, 3, 4, 5, 6 of its own, 2 that it received with a -2 charge. So then our formula is Li2S. Now, if it had just asked you to find the formula and you didn't have to do this electron dot stuff, like it was a part 1 question, then you could do like we did in the original learning about this back a couple topics ago. You would look up lithium and see that lithium has a +1 charge, and look up sulfur and see that sulfur has a -2 charge, and then you could just crisscross and get Li2S, okay, which would give you the same answer as there. So all of this isn't necessary just to get the formula. You can still do this crisscross part where, remember, the net charge has to be 0. So if there's 1 positive, 2 negatives, I'm going to need 2 of the Li's to make 2 positives, 2 negatives. That's still our goal, is a net charge of 0. It's just that this steps are now an additional thing that we're learning. If it was like a part 2 question, you would have to show this part. Okay. All right, and then MgO. So Mg has 2 valence electrons, and oxygen has 6. So this magnesium is going to give 1 here and 1 there. Magnesium has lost its 2. It's happy. Oxygen has gained 2, so it's happy. So we have Mg with a +2 charge. We have oxygen with 6 of its own, and then the 2 that it gained. So it has a -2 charge. +2 -2 is why we get our MgO for our formula, which is what we started with. And then to name it, magnesium oxide. Remember, no prefixes, nothing like that. So just like in this one, it was lithium sulfide. We don't say like dilithium sulfide or anything like that. Okay. So those are the first 2. And then the second 2, we're on page 9. Same thing for you to do number 1 and number 3. So we have potassium chloride. So potassium is K. I'm going to do the formula this time. If I look it up on the table, it has a +1 charge. Chlorine has a -1 charge. So I know my formula is going to end up being KCl. So this time I just started with that. Potassium has 1 valence electron. Chlorine has 7. So potassium is going to give 1 electron to the chlorine. Potassium is your metal. Chlorine is your nonmetal. So now we can see where this formula comes from. So we have K, it lost 1, so it's a +1. We have Cl that had 7 of its own, and the 1 that it gained. So chlorine has a -1 charge. So KCl is our formula. Okay. And then the last one, I know my formula is ZnCl2. So for me to name that, I know it's zinc chloride. For me to now do my electron dot, if I look up, zinc has 2 valence electrons. Chlorine has 7. So zinc's going to give 1 to the chlorine. We need another one. Zinc's going to give 1 to this chlorine. So zinc has lost its 2, it's happy. Chlorine has gained. So we have zinc with a +2 charge. And then we have chlorine with 7 of its own. 1 that it gained. So chlorine has a -1 charge, and there's 2 of them. So then we get our formula ZnCl2. And if I had done it by looking up the charges, zinc would be a +1, chlorine's a -1, or +2, excuse me, and a -1. So when we crisscross, we get ZnCl2. Okay, so that's your 2 sets of homework. So what I'd like for you to do for tonight is we're going to do 2 and 4 together on page 9. They're a little bit different because they have the parentheses with the double charges, and this one has another little kind of trick in it. So we're going to do 2 and 4 together, and then I'm going to have you go ahead and try 2 and 4 on page 9 by yourself, and then I have some quizzes questions for you. Okay, all right, so go back to page 8, and we are going to look at number 2. So we still have our metal for iron, our non-metal for chlorine. This Roman numeral 3, remember, tells us that we're talking about iron with a +3 charge. So it doesn't mean that there's 3 iron, it means that it's iron with a +3 charge. Okay, so I can start off then right away doing the formula first if I want to. So I have Fe with a +3 charge. I have chlorine, if I look up, has a -1 charge. So if I crisscross, I know my formula then is going to be FeCl3. So I kind of already know now what my electron dot is going to look like. Or if you had wanted to do the electron dot first, you can do that too. So by it telling me +3 charge, that's telling me that I want iron with 3 valence electrons. So +3 charge, Roman numeral 3, must mean that it has 3 valence electrons that it wants to get rid of and become a +3. And then I have chlorine that has 1, 2, 3, 4, 5, 6, 7. So it's pretty easy to see. Iron's going to give 1 here. I'm going to need another chlorine for this one, and then another chlorine to give to that one. So iron had its 3, chlorine has 7, only needs 1, so I'm going to need 3 different chlorines for each of those. So I have iron with a +3 charge because it lost 3 electrons. Then I have chlorine with 7 of its own, the 1 that it gained. So chlorine has a -1 charge, and there's 3 of them. So that's where my FeCl3 comes from. Okay. And then when I name it, I have to say iron 3 chloride, because if you look up, iron can either be +2 or +3. So those are our transition metals that have more than 1 charge, and they have color to them, that sort of thing. Okay, so that one was a little bit different than what we did the day before because of this Roman numeral 3. Just to refresh, that's the only thing that was different about it. Okay, all right, and then the last one that we're going to do together, chromium with oxygen. So we know that our name is going to be chromium, and then O, oxygen, so chromium oxide. We know that that's going to be our title. When I go up and look up chromium, it's one of those transition metals again that has different charges that it can be. It also has kind of a goofy valence electron situation. So we're going to have to use the formula to tell us what the chromium is. Okay. All right. So if I have CrO3, what do we know that the charge of oxygen is? So oxygen is -2. Okay, we know that oxygen's only charge can be -2. So if I have 3 at -2, then I have a total of 6 negative charges. So in order for this formula to be balanced out, I have to have a total of 6 positive charges as well. And there's only one of the chromium, so that chromium must be a +6. So this is a very strange one where we have chromium with 6 valence electrons. And now we would typically say, well, why would it be losing 6 then? Because it's a metal and it's with a nonmetal, and because there's always some weird exceptions to the rule in chemistry, but metals and nonmetals are always going to be transferring electrons. And because chromium is a metal and oxide is a nonmetal, even though it's 6 and it'd be much easier for it to gain 2, metals don't gain electrons. So this is just a weird anomaly, and unfortunately sometimes the Regents likes to give you weird anomalies, so I wanted to make sure we did one. All right, so we have chromium with 6 valence electrons. So we've got chromium with 6, and then oddly enough, we have oxygen with 6. Okay, so the chromium is wanting to get rid of these electrons. We already know CrO3 is going to be our formula, so it's kind of like we already know what we're going to need to do, but I'm going to give one here, and I'm going to give one here. So this oxygen is all set. It's got its 6. I still have these, so I need another oxygen. I'm going to give one here. I'm going to give one there. This oxygen has its 6 of its own, 8 that it got back. That one's happy. And then I have 2 more, so I need 1 more oxygen. And we're going to give one here and give one here. Okay. So I end up with chromium with a +3 charge. And then I end up with oxygen that has 6 of its own. Each oxygen gained 2. So each oxygen has a -2 charge. And there were 3 oxygens, so Cr3. So that's where CrO3 comes from. So to go back to name it now, chromium oxide, I have to indicate which chromium it is. It was a chromium with a +6. So we need to have chromium 6 oxide to get our full name. Okay. All right, so you guys are going to do on page 9, you're going to do number 2, which C has the Roman numeral, so that's a little bit different about that one. And you're going to do number 4, which is with vanadium, and you kind of got to work backwards like we did with the chromium one. Okay, so you're going to do number 2 and number 4 on page 9, and then I'm going to have a quizzes that's just kind of general questions about ionic bonding. Okay, thanks guys.